All right, everybody, we just got it okay to start our final planetarium show of the day. So I'm going to put away our space trivia questions because now, folks, we're heading into the unknown. And welcome, everybody, to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls, I'm actually a person, and I'm standing right behind you at the very top of the planetarium. Hey, good afternoon, everybody. Don't hurt your necks, though. Look forward into the dome before you. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below that purple glow all throughout our room. And I want to let you know, folks, that the show that we're doing right now is different from all the other ones that we've done here today. This one's called Tour of the Universe. This show is completely live, so you're going to hear my voice for the next 30 minutes. And we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things. And also, before we get started with the show, I got to go over some quick house rules just so that we're all on the same page and have a good time. First off, folks, there's no food or drinks allowed in. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep this place as clean as possible. Also, if you happen to have any cell phones, smartwatches, make sure the flash is turned off, and also make sure those devices are put away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. And folks, if you need to leave early, the exits are going to be at the very top of the planetarium. So always make your way up the stairs to exit. If the staircase is too steep for you to climb, don't worry, just remain seated for a little bit longer. Once the show's over, we'll have a staff member escort you to a lower exit. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, well, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths. Then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling all the way to the edge of the observable universe. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. All right, everybody. As I mentioned, we're going to be starting off pretty close to the planet. We can see the Earth just down below with all the city lights. But we're going to be starting off here at this really cool spacecraft in front of us called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what's the International Space Station? I always hear about it in the news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks, the International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct so many different types of science experiments up here. Some of the things they'll conduct are things like what happens when you try to spark a match in space? How does a flame act differently with less gravity? Another one is what happens when you try to grow plants in space? Which way do the roots grow with less gravity, of course? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compare and contrast the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have as much gravity working down your muscles further away from the planet. So if you plan to live in space for a long, extended period of time, remember to exercise daily. And also, folks, the International Space Station looks really big here in our planetarium dome, but it's not too big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry. You can also use the entire museum that we're sitting in, the California Academy of Sciences. That's roughly how large it is. And also, what's really impressive is that the International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. Also, this looks really far away from our planet as well. But the International Space Station is only about 250 miles above the surface of our world. 250 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So, not too bad per se. But to tell you the truth, folks, this is as far as we put humans into space nowadays, only 250 miles above the surface of our world. The reason why is because traveling into space is quite expensive. You got to build yourself a rocket ship, buy yourself one, or pay for a ride. And once you've done that, you have to account for all the rocket fuel. You need so much rocket fuel, you got to be able to escape the Earth's gravity. And once you acquire all that, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill gets quite costly quite rapidly. But the International Space Station is just the first stop on our tour of the universe. So now we're going to see it slowly fade away to those city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it as it slowly disappears. And now, folks, we're able to see our entire planet Earth from this perspective. And I want to let you know that the space program that we're using here inside the Morrison Planetarium is something that you can go home and download if you want to fly through space just like how I'm doing. The space program that we're using here is called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, or go to www.openspaceproject.com, you can come across the link where you can download this and you can fly through space. What's really amazing is that this is an open source software. So that means anybody can add to this software. So if you like building computer models of spacecrafts, you're more than welcome to add to it. And also, this isn't entirely finished. OpenSpace is in its beta phase. It's not completely finished. So we may come across a few bugs and glitches. If we do, I'll point them out. Hopefully, we can look past them. It's such a fun software. And also, this uses a whole lot of real time data. We're pulling satellite imagery from satellites that are in space, and everything that you see right now, that's the weather, what it looked like yesterday. So if you have an older computer, you may not want to download it, it may overwhelm it. But if you got something new like a gaming computer, give it a try. It's a whole lot of fun. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredible lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans to Mars, we need to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone to figuring out the logistics of doing that. And what's really impressive is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and that's going to be very helpful because we can melt that ice, pass electricity through it, separate the hydrogen and the oxygen, and both that stuff's really valuable when you're far away from home. So look out for any news about Artemis in the coming years. We humans should be heading back to the moon relatively soon. And folks, when we look up at the moon here from planet Earth, sometimes it feels incredibly close to us. Feels like you can reach out your arms and touch it. But the moon's incredibly far away. It's about 240,000 miles away from our planet Earth. Whew, 240,000 miles? Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour. Although we don't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, well, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye bye, moon. So cute. And now, folks, just like how we saw before with the International Space Station, we're going to see the moon start to slowly fade away. And before we lose track of the moon, I want to add some nice planet trails so we can see where everything is out here in space. And on our journey today, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer programs like OpenSpace showing us the most accurate images and information available to us. And now, the nearest star to us, the sun, should be coming into view. So here comes the sun. Do 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 do. And folks, the sun is also incredibly far away from us as well from Earth. It's about 93 million miles. Whew, 93 million miles. That is a good distance away. And in order for sunlight to travel that 93 million miles, it takes sunlight about 8.5 minutes at the speed of light to get all the way to Earth. 8.5 minutes. Not too bad. And this is a great concept to keep in mind because it takes light a while to travel really far distances. And that's really important, especially when you're looking at objects that are really far away from us. For example, let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So the more further, so when you're looking at objects really far away from space, in space, it's kind of like looking back in time in a sense, which is really cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have. Right in the middle, we have our star, the sun, the biggest thing by far. The closest planet to the sun, we have Mercury. Then we have Venus, and then Earth. That's us. And then past Earth, we have Mars, the red planet. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have the main asteroid belts. And this is what it would look like if we were to highlight all those asteroids. There's roughly about 1 million asteroids in this region, give or take. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all, Saturn, famous for its rings. And then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto on screen. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. So the Kuiper Belt is like a second asteroid belt past the orbit of Neptune. And what you're mostly going to find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. And what's really incredible is that our technology greatly improved in 2006, so we're able to see much smaller objects much further away. And we came across more than 400 objects out here in the Kuiper Belt region. Some of this stuff was bigger than Pluto, so we couldn't call all these things planets. There was just way too many of them. So all the astronomers on planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And they came up with 3 different criterias. And folks, that was the day in 2006 that Pluto went from being a planet to a dwarf planet. And I know a lot of people still have hard feelings about it. I still do a little bit. But that's the really cool thing about science, because as our technology improves, we're able to make better observations so we can change, better fit our things that we need. Sorry. So that's the really cool thing about science. It's constantly updating and changing. So yeah. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now on screen, I'm going to be adding on screen the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction just on the right-hand side. Now, all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours to get all the way out here. Not too bad either. But now, folks, it's time for us to leave our planetary scale behind us because now we're heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri is just on our top left side. So we're right in the center. A little bit to the top left, we have Alpha Centauri. And again, 4 years at the speed of light just to reach the next star system to us. But that doesn't put into perspective of how long it would take us humans to travel that distance. Well, folks, if you got in a rocket ship today, made your way over to Alpha Centauri, it's going to take you roughly about 8,500 years to make that journey. And that's just a one-way trip. Whew. But let's stop consider whether humanity has made its presence known beyond our solar system, because now we're stepping inside something called the radiosphere. And again, we're now inside something called the radiosphere. This represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So, is anybody out there listening? And now, folks, I'm going to be adding some many markers onto the screen. These many markers indicate so many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. Now, to say if any of them are Earth like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed right now, so they're in the laboratory, then they got to get launched into space and then conduct science. So we've got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. And of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet markers, but I'm going to leave our radiosphere up on screen. Because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, everybody, we're now looking down on our Milky Way galaxy. This is a galaxy we live in, and I've got to ask, can anybody see their house from here? Just kidding. And folks, our galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you roughly about 130,000 years at the speed of light. And our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave our Milky Way, I want to show you what it looks like from the side. You're going to notice that we live in a big flat spiral disk of the Milky Way. Kind of looks like a big frisbee or a pancake in space. And this is important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south. Instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. That's going to come important in just a little bit. And folks, the Milky Way is only one of many hundreds of billions of galaxies that comprise the known universe. So, in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies are not evenly distributed throughout space, where there's one galaxy here in a nice little neat line or another galaxy here as well. Instead, galaxies like to clump together in large groups and clusters, or they create voids where there's very few or no galaxies at all. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And this picture that we're now looking at, folks, represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tully, who compiled this amazing representation thanks to the work of other astronomers working aside him over decades of time. So, big shout out to Dr. Brent Tully. But now, folks, we have automated systems that are mapping even the most distant galaxies. So, now we're about to see the large scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And as we start swinging around, you're going to realize that the large scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of the Milky Way? Well, if you line up our Milky Way galaxy, it would line up just down the middle like so. And again, we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that those galaxies through the plane of our Milky Way, so we have this purple survey of galaxies. You'll notice that we are still able to find them, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these areas that haven't been mapped out yet, so it's just a matter of time. But let's continue pressing on, folks, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are short for quasi-stellar radio sources, and they're going to be represented by orange dots on either side of the large-scale structure of the universe. And these blazing objects, or quasars, are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. And what we're looking at is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this picture is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color coded with the lighter areas corresponding to the hottest, least dense regions, and those darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. they vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to that large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But, folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go back home, towards planet Earth. So, let's find a nice entry point through all these quasars and galaxies. Ooh, this looks like a good spot. And let's make our return trip back to planet Earth, everybody. All right, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everyone, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope. And there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way galaxy. We're heading straight for that radiosphere. And now we're making our way to our star system, our solar system, our little neighborhood in the vastness of space and time. And now we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto in the Kuiper Belt region. And now we're making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank you so much for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound just in time for dinner time. And that's all the time that we have for today, folks. I hope you get home safely, and we'll see you next time.